Hi, welcome to Math as a Language. In this video, we're going to discuss a topic that has, it's not a major topic, but it has come up from time to time. Perhaps you've even wondered about it yourself. But here's the thing. Most schools, many schools, not all, but many schools, in many schools, students take Algebra 1, then they go and they take geometry. They're placed in geometry. And from the geometry, again, they continue their algebra experience, and more often than not, they go back to Algebra 2, okay, in the math sequence. And I think what we'd like to talk about today is why this sequence, if you will. And we think this is a good time as any to talk about the fact that we firmly believe it has to do with the fact of the matter is that math is a language. And we believe firmly in that math is a language. And as such, like any other language, it might behoove us, before we go too far in learning the language, that we recognize that there are rules to the language. All right? So in English, now you can learn to speak English without knowing the rules. But no, I'm sure English teachers will be happy to have us acknowledge that there are rules to English. You have your grammar rules and sentences, and you have to understand what of nouns and verbs and sentence structures are, and being able to construct very grammatically correct sentences. So the rules exist. What we would like to say here is that in mathematics, those rules also exist. That math also, as a language, has its rules. And in fact, it's very easy for students to go through algebra thinking that these rules are not recognizing that these rules exist. And certainly in algebra, we would contend that the rules are not brought to the forefront. They're not the major part of algebra. That is to say, in algebra, more often than not, you would be given an equation, perhaps an equation of this sort. Let's go with a 3x plus, let's go with plus 4 minus 2x is equal to 7, let's say. Okay. So you're given this equation, and more often than not, your first instinct, of course, is to solve it. So in solving this equation, let's say that you were to do this. You rewrite the sentence so that it's 3x minus 2x. We bring this 2x over, and then the plus 4 is there. We put that 4 there, and equal to 7. We know that these guys are like terms, the 3x and a negative 2x, and so that could become a 1x, I should say. 1x, yeah, 1 you don't need to write it, but 1x plus 4 is equal to 7. And then your next step would be perhaps to subtract the 4 from both sides. Take away 4, take away 4, and finally your answer is x is 3. Alright, so x is equal to 3. You've solved the equation, you box it, package it up, it's a good deal, you're good to go, x is 3. Alright, some instructors would ask that you check it, to check your solution to make sure that it's correct. You place that 3 back in the original equation perhaps and have it check out. And that would be a done deal. Here's the thing. In geometry, what we want you to recognize is, in geometry, the reason why we place geometry where we do is we want you to concentrate, to focus on the why. Alright? That is to say, all of the steps that you took in algebra are correct and legitimate steps. Alright? But know that we have names and rules for these steps. We have postulates and theorems and corollaries and various identity rules and so forth that justifies these steps. Okay? So the key word here is that in geometry we want you to justify your steps. Okay? justify why it is that you can do what you did to get this answer. All right? And therein lies the focus in the geometry. So we'll do, a real brief treatment here. So more often than not in geometry, the first thing you would do is you would identify these statements. You'd number them, okay? After you've numbered the statements, then you need to justify where did this statement come from, okay? And so let's say that the first statement is given more often than not, and this is the format that we use in a two column proof is what it's called. But you're given a statement, and then you really need to, in geometry, provide the reasons for each of these various steps. So your second step here, all right, and know too, we should say that these rules exist in algebra. It's just that they're not the highlight of the algebra. They're not the focus of the algebra. Right, wrong, or indifferent, the focus on algebra is getting the answer, whereas the focus in geometry are the reasons for these statements. All right. So in this case, we took this negative 2x and we moved it, or we switched these guys, and there's a property. That property exists in geometry, in algebra as well. It's called the commutative property. So you exercise the commutative property here. Commutative property. The commutative property says that you can switch locations, switch the positions of two addends in a statement. All right, and then your next step. Why is it that 3x and 2x becomes 1x? Well, it depends on your proof or your text, but more often than not, this step is called simplifying. That is to say, why use two spaces when you have an equivalent expression or equivalent value that can take the place of these two guys? So we want things to be simple in mathematics. All right, and then finally, your next step here, step 4, would be you have a 4 on this side, the 7 here. Obviously, we know that in order to keep equations balanced, that we can subtract 4 from both sides. So that would be your subtraction property of equality. Okay, and then finally, this last step, you started off with x here. You subtracted from both sides. So essentially, you can just say simplifying. Some textbooks you might call that substituting away. Not substituting, but perhaps a transitive property. Depends on the approach, and know that these properties and rules can be sometimes used in different instances in different situations. All right, but here's the key to what we're talking about here. Is the fact of the matter is, what we want you to recognize is that these rules do exist. All right. So all of these properties and rules and theorems exist. They also exist when you're doing the algebra. They exist here. We use them here. It's just that in geometry, this becomes our focus. All right. This becomes the focus of the geometry. And the reason why it becomes the focus is, simply put, we do not want you just going on from Algebra 1 to Algebra 2 and not recognizing that these subjects, these areas, are built upon statements and rules and justifications, just as we do in English. Mathematics is built upon a foundation, and that foundation essentially has to do with various postulates, properties, theorems, and rules. Okay? And so that's basically why we placed the geometry where we do, is that we want you to learn to appreciate the fact that mathematics is not just a case of finding answers, all right, though that's important. But we do want you to know that we also want to know why that answer is what it is, and you need to be able to, we need to be able to, in mathematics, to justify the steps we take in terms of finding that solution. All right. Thank you for listening and visiting us, and we hope to see you soon in the next video. Take care.